In this third video, I'm going to show yet another method for defining tendon geometry within RM. So here I am starting again with the same model, a 3-span pre-stressed hollow box bridge. In the previous two methods, the tendon geometry was defined by changing the point through which a tendon profile was referenced. So in method 2, the tendon was defined as passing through different points along the length of the bridge. And in method 1, the tendon was referenced to different points, one at the top and one at the bottom of the section. In this third method, what I'm going to do is have the tendon always be referenced to the same point. It's always going to pass through the same point, and then what will happen is that the location of that point is going to change along the length of the bridge. So to do this, I'm going to show the setup for it in the cross section. So what you see here is I've cleaned up this cross section except to show the construction lines that define the webs and also the top of the section. And I'm going to need a couple more construction lines here. The first thing I'll do is create a construction line in the middle of the webs. So I've changed the color to blue so it will show up better, and now I can create this construction line right through the center of that web and this construction line right through the center of the other web. Now what I want to do is have the tendon profile vary up and down along this line here. So to do that, I'll need a construction line that has a variable depth or a variable distance associated to it. So I'll create a cross-section variable here. And I'll name this tend-d for tendon depth. And I'll give it an initial value of 0.4 meters. And say OK, and now I'll activate that. Now I can, using this variable, define a third construction line here. So now what I've done is I've generated this intersection point right there, and as this variable value changes from 0.4 to 1 meter, this line will move down, and that intersection that I'll use is going to vary up and down the web as you see here. So I'll set that back to 0.4. Next, I'll need the geometry point that I'm actually going to use. So I have a reference set of geometry points already defined, and I'll activate that, and then I'll place a geometry point. And here at the intersection of these two new lines I created, and I'll call this tendon point left, and I can create one in the right web as well. Tendon point right. So now those 2 points are created, and what I need to do is vary the depth of this point. So I need to vary this construction line. And to do that, I'll use a table. And if you've gone through the pre-stressing basic example, you'll learn how to use the tables. The tables were used to define the variable height of the cross-section in this example too. But now I'm going to create a table for varying the depth of that geometry point. And I'll call this, I'll give it the same name. So I'll input the first point at the very beginning of the bridge, and it will have a depth from the top of the cross section of 0.4 meters. The next point then will be 12 meters along the length of the bridge, and it will have a depth of 3.3 meters. And I'll start to see this diagram come to shape. And one thing to keep in mind here is that it's not really important for me in this case what the interpolation is between these 2 points. They're just going to be used as 2 points here, and the tendon profile is not going to follow the shape of whatever this graph is. This diagram is just going to show, I'm just going to use it to give me the points where the tendon's going to pass through. So now I'm going to fill out the rest of this table with a few more points. Now I've finished defining this table, that all it's going to do is move those 2 geometry points up and down in the cross section along its length. And if you look at the diagram, you can see that this point will move between 0.4 meters from the top of the section to 3.3 meters from the top of the section. And again, the interpolation between these points is not important here. What I'll do then is I have to remember to assign this to the cross section. So if I come to my segment and the variables tab, I'll find this new variable cross-section dimension that I defined, and at all points I'll want to apply this table. I'll append that and apply. Okay. And now I will update the model. So here I'm going to create this model and just keep and overwrite everything that I already have. So I'll run that. Now I come back out here to my model, and I can again first define the tendon. So this will be very similar to the last example. I'm just going to define a tendon named 101. I'll again make this a master profile and then assign a material to it. This master profile will again pass through all of the elements of the superstructure. So I'll put 101 through 135 and say OK. And now we come to the Geometry tab. And here, the first point will again be referenced to the very beginning of the bridge. And I'm again going to choose a cross-section point. So this is still very similar to method 2. And then I'll choose that cross-section point. And now here, come to this tendon points, and I'll choose the tendon point in the left web and say OK. Again, I don't need to give a vertical offset or a transverse offset because this point is already exactly where I want the tendon to be passing through. And then I'll set these angles to free so that it's not fixed at any angle. So far, everything has been very similar, at least in the tendon geometry setup, to the way it was with method 2. However, with method 2, what I ended up doing then was defining the next point and referencing it to a geometry point at the bottom of the web. Here, I don't have to choose a point at the bottom of the web because this geometry point is actually going to move to the bottom of the web over the length of the bridge. So I can actually just copy this point, and all I'm going to do is change the element number to 104, copy it to element 111, copy it to 118, halfway through the element, that's the midpoint of the bridge, then copy it to element 126, 133, and 135 at the end of that element. Now I'm going to go back and change these. Accidentally made those at halfway through the element. So now I've assigned this rather quickly instead of going through and changing the cross-section point. These are all assigned to tendon point left, and this actual point is what's changing. So now if I come out to my 3D view and again do a cross-section calculation and a structure check, I'll recalculate here, turn off some of these view options, and now I see that exact same tendon profile that I had defined using method 2. Just with this method, the point that the tendon passes through does not differ, only the location of that point has changed. And again, I could do this same method for copying. So I could copy this tendon profile and then use a TCL file to change this to tendon point right, or even just come in here after I copied it and change them all to tendon point right.